In this recording, we're going to look at some transformed sinusoids, which is a fancy name for sine or cosine waves. And we're going to continue to look at some of the details of the graph. And either the graph's going to be presented as an equation or in graphical form like you see here. And so first off, we're going to start to figure out the amplitude of the graph. So, pen. The amplitude of this graph is the height of this graph above the nodal line. So you can see this graph goes one above and one below the x-axis. So we'll just say that the amplitude is 1. Another way to think about it is it's half the difference between the highest and low point. So highest to low point is 1 minus negative 1. Double negative makes positive, all over 2. So when I make that a plus plus, 1 plus 1 is 2, 2 over 2 is 1, which gets us back to here. I'm using that definition. Next I'm going to look at the frequency. Now we said frequency is defined as how many cycles we complete within a 2 pi interval. Excuse me. I'm just going to follow this graph along until I get to 2 pi. Well, it looks like it hasn't completed one full cycle of sine yet. So my question is, how many cycles has it completed? And it looks like it's only completed half a wave. So the frequency is half. Next we're on to the period. The period is defined as how long it takes to complete one full cycle. So again, not a full cycle yet. And then yes, it has completed a full cycle. So 4 pi is the period. And finally we get to the vertical shift. How much above the x-axis is the nodal line? Well, it's none. So we can just say 0. Another way to think about it is, we take that formula, it's the average of the high and low points. So the high point was 1, the low point was negative 1 in terms of the y values. We average those out. Again, we get a 0. That's the same as we got down here. Let's look at the second example. This one is clearly shifted down. So the first thing I want to do is draw in that dotted line. Come in here and make a dotted line where the nodal line is. And I'm just eyeballing it, making sure there's the same amount above and the same amount below. So it looks like 3 below and 3 above. I didn't really draw that very well. Let's undo that. Try that one more time. 3 above. Nice. So, when we're talking about the amplitude, it's the height of the wave above the nodal line. So it's 3. Another way to think about it is, if I come over here, it's the difference between the highest and lowest points. So you can clearly see there's 6 there. It's the difference over 2. Again, that's 3. Frequency. Okay, I want you to see if you can figure out the frequency of this graph, and then the period as well, and then play the recording when you've thought about it. Okay, so the frequency of this graph. Frequency is defined. Grab a different pen. Frequency is defined as the number. Remember, frequency is a number. How many waves within a 2 pi interval? So I'm just going along here until I get to 2 pi. That's a full wave of cosine. So it's just 1. Period, on the other hand, period, if you think about it intuitively, period is an amount of time. You know, for what period of time were you in class or something like that? So the period is, I'll grab my other pen here. Period is how many. Remember, period is what period of time it takes to complete one cycle. So I'm going to go all along this to see if I complete one cycle. And the period is how long it takes, and that's 6.28, 2 pi. Of course, those kind of work together, because the period is 2 pi divided by the absolute value of b. B is always the frequency, and when I sub in a 1 for the denominator, I'd get 2 pi which corresponds, looks like that's out of bounds a little bit. That's going to correspond to this value. Finally, the vertical shift. What does it look like to you? How many units above or below the x-axis is the nodal line? Hopefully you'll see that it's down 1 unit. It's 1 unit down. And again, you could use your average formula. So if I average 2 plus a negative 4, the highest and the lowest y values, if I average those out, add them up, divide by 2, we get a negative 1. And that's the vertical shift. Next kind of thing we can do is we can take an equation and then we can try to figure out the details of the graph without even peeking at the graph. Of course we can always pull out our graphing calculator and confirm these answers, but let's see if we can just get the details of the graph here. So instead of giving definitions, because we can't see the graph, I'm going to look at this most complicated example here in the bottom left corner. It says y equals half cosine of 2x plus 1. So I'm going to put in some definitions in terms of the parameters of the graph. So I know that amplitude is the absolute value of a. Well, a is the number in front of the cosine, so it's just absolute value of half, just half. Okay, so that means it goes half a unit above, half a unit below the nodal line. Next, I'm interested in the frequency. Well, frequency is the absolute value of b. In this case, b, and I think it might be helpful, let me write over in this space the sort of generic format. So we say it's y is equal to a times the cosine of b x minus h plus k. We don't have any minus h in the example we're looking at. So it's really just the b that we're looking at. If you remember, that's the frequency. The a that we're looking at, that'll tell us the amplitude. And finally the k, which is the vertical shift. Confirm all this with your calculator. Okay, so b value is 2. We also need over here, I'm going to jot down a formula that we need to know. The period is 2 pi over the absolute value of b. Okay. So 2 pi over the absolute value of b, in this case b is 2 pi over 2 pi. So that means it completes a cycle within pi radians. Frequency, again, that means it completes 2 cycles within 2 pi intervals. And finally, the vertical shift is just up 1. One nice thing about the graphing calculator is we can just pop this function into the graphing calculator and confirm that all the characteristics, all the details of the graph are there as we expected. So the first thing I'm going to do is make a horizontal line right where we think the nodal line is going to be. We said the nodal line, or the vertical shift, is going to be right here at y equals 1. Looks like it splits the graph pretty well vertically. And we said the amplitude was going to be the amount above or below the nodal line. So yeah, looks like about half a unit above, half a unit below. Seems to be confirming what we're saying. The frequency, well, way out here is 2 pi. Okay, 3 pi over 2 and pi over 2. So we're tracing along this graph. We're seeing our frequency is how many. So that's 1 cycle, 2 cycles. So 2 cycles within a 2 pi interval. Check, check. Period. Period is how long. Remember, think period. How long were you in school? How long were you in second period? a how long question. So how long to complete one cycle? Get a different pen. Go with black. Okay, so cruising along here. How long until we complete one cycle? There's a cycle. Pi. Check. We already had our vertical shift. Check.